Our mission with Flood Platform is to unify flood modeling by providing a platform that empowers modelers, engineers, stakeholders to collaborate, optimize solutions that address the challenges of climate change. And this builds on our decades of experience in providing flood risk management services across the globe and a deep understanding of the challenges faced by practitioners and suppliers. Flood Platform is designed using Jacob's experience of flood management and product design capability combined with extensive research into practitioner needs. So in designing Flood Platform, we've asked the industry, what are your biggest pains and your challenges? What's your vision for the future of flood modeling? We've asked these questions of users, practitioners and stakeholders from a range of different backgrounds and geographies, and to be honest, we received remarkably consistent feedback across 4 broad themes. I'm just going to dive into some of these themes in the next slide. Collaboration, it was a leading theme, a leading pain point for many of our users. So collaboration is essential to achieving the best outcomes, providing team members, colleagues, partner organizations and clients with access to models. This allows them to provide comment, undertake review, quality assurance, and generally improve the quality of our projects which we're delivering. But this is often stifled by the size and complexity of our models and the tools we have available to facilitate this collaboration. It's not easy to share a model from one organization to the other due to the sheer size and complexity of the models we're producing. In addition to collaborating on model data, there's also a need to collaborate better when it comes to reports, deliverables, outputs from models, a more consistent and efficient way of producing those. Equally, shared best practice. All our teams, our clients and other partners are producing new tools, new ways of working, and we want to make sure these are easy to share across the community so we can all leverage the benefits. Data. I'm sure if modelers find data the absolute bane of their lives. We're building bigger and bigger models, and there's an absolute challenge there for us locating enough storage space within our organizations to handle the quantities of data we're producing and store that in a sensible, structured way. I know certainly our IT department was very keen to let us know how much data we're generating. And once you've generated that data, transferring it again to other partners or your clients is really challenging because you need to find ways of moving large quantities of data, and that inhibits that collaboration piece. When it comes to large amounts of data, we've got particular issues around version control and provenance of data. Where have these data come from? Who produced them? What has changed with them? How have they changed during a project? A lot of these data are, this information isn't recorded, and it's hard to recover it once a project's in train. So it's really important we have a better way of managing our data, our version control, and our provenance. Equally, when we have data at that scale, there are some fantastic tools available now to enable visualization and analytics of that data, but the data is often not structured or categorized in the right way to enable these tools to be used. So we need a better way of managing that data. Also, at the end of projects, when we've completed a project, there's a big challenge there about archiving that data and then potentially recovering it in years to come for new projects or subsequent stages of work. Technology, we've all seen major shifts in technology over the last 5 years alone. Machine learning, AI, and data science tools have been impressively improved. We can see the opportunities these bring for bringing more efficient ways of working, bringing better outcomes for our modeling, but we often struggle to apply them in a consistent way because they are complex. And again, coming back to the way we manage and sort our data. And these tools will bring great benefits. They'll allow us to avoid rework, getting things right first time, optimizing our models so we can calibrate them better and faster, and ultimately optimizing the solutions our clients want, whether that be flood risk interventions, flood forecasting systems, and so on. Another big challenge with technology is managing simulations. Certainly within Jacobs, we're running hundreds of thousands of simulations every day across our teams, and finding good ways of managing those simulations, keeping track of what's going on, effectively using our licenses and our computer resource is a real challenge for us. And finally, data security. That's the wrapper around all of this. We're generating large quantities of very sensitive data, and our clients want to have trust that that's under control. So providing excellent access control, enforcing policies, and demonstrating compliance with client requirements is an essential part of our tool. This brings us to Flood Platform, a tool which will unify flood modeling. This is a tool Jacobs have been using internally with our teams over the last 15 years to deliver the vast majority of our modeling work. It's used by our teams across America, UK, Australia, India, and elsewhere to manage model data, bring files together, collaborate across projects, and work efficiently with all our compute resource. We're now going to bring that as an external product so anyone can access that system. Out of the box, the system will work with HEC-RAS, EPA-SWMM, Flood Modeler, and TUFLOW, and we'll carry on adding more solvers as we develop the tool. Core features in Flood Platform are around model management, so good way to managing your data, be able to version control, track changes, and other elements. Be able to visualize your data. I'll show you this in a minute. So not just being able to store your data somewhere and see in a list, but actually visualize all your data components, including model results, both 1D and 2D. Simulation and analysis within Flood Modeler, within Flood Platform, you can run dozens, hundreds, thousands of simulations in the cloud using any of the solvers available, and then undertake detailed analysis of those results. The model management and data management tools also allow easy collaboration, both across your team, so between individual team members, across organizations, with partners, subcontractors, as well as with clients and stakeholders, and I'll show you some of that shortly. Reporting will be baked in, so these are automated deliverable production, whether that be model logs, model passports, model reports. Because we're organizing the data in a sensible way, we can rapidly and automatically produce standardized deliverables, saving you time and effort. As I said on the previous slide, security and compliance is essential to us, making sure you've got trust that your data is secure and you've got that granular control over who can access it. Here I'm just providing a very high-level overview of how Flood Platform works. So Flood Platform is a cloud-based tool to manage your models and your data, which is accessed via a web browser. All users access the system via a secure gateway, whether they be model creators, so the model owners, stakeholders who want to view the data, or clients who want to access their results. They all go through the same gateway. This provides robust security and permissions management. Once you're connected, users have access to a range of tools covering, I'm not going to go into all of these, but they'll be able to upload and manage models. They'll be able to initiate simulations and build new simulations and track those simulations in flight. They'll be able to view their models both as spatial data and tabular data, so visualize the results, look at levels, look at flows, see what those flood maps look like. We've got built-in quality assurance checks and frameworks to allow you to assure the robust modeling. We've got the report builder I mentioned earlier, the ability to share and transfer models between yourself and your clients, the ability to undertake detailed analytics, including model calibration, uncertainty and probabilistic analysis, and design optimization, as well as tools like model archiving. All this is supported by large data availability. So we've got a large repository of data to manage your models and store them securely. Automations, tools which are baked into the software which automate common modeling tasks, saving you time and effort. A wide range of modeling applications available, and these, as I said, are HEC-RAS, EPA-SWMM, TUFLOW, and Flood Modeler, with more to come. An elastic cloud-based compute, so you can access unlimited CPU and GPU compute, so you can run as many models as you need to, speeding up your program and reducing risk. And we're also adding in machine learning and AI capability to really get the best out of your model results and your analysis. Flood Platform, I say, is cloud-based and it's accessed via a web interface. So when you first log onto the system, you're presented with a logon screen, and from here you provide your credentials. By default, we're using two-factor authentication and rigorous security tools to ensure that only you can access your data. It's the same portal you log on, whether you're a user producing models, a client wanting to look at those results, or a stakeholder wanting to comment on some of the work you've undertaken. Once you're into Flood Platform, the core of it is around your model space. This is where you can store your models and your data. And we've broken these up into workspaces and projects. I'll talk a bit more about projects in a minute, but they're individual. We envision being individual commissions where you're undertaking specific modeling work, whereas workspaces are a collection of projects. The workspaces are flexible, and it's down to the user to define how they want to use them. It may be a workspace is for an individual client where you've got all your client projects under one workspace. It may be for a given region, or it may be for a given project team. By allowing you to group your projects by workspace, you can provide very granular permissions and who can access that data, both inside your organization and outside, so you can collaborate with other organizations via Flood Platform. When you set up workspaces, you have to give them a name, optional project code, which organization they relate to, and you can also provide geofencing, so you can specify that workspace in a particular geographic region, so you know all that work is in one location. It helps you manage that data and helps you manage the compute associated with it. You can also provide those granular permissions. You can decide who within your organization can see that workspace, who can edit the workspace, who can create projects within it, who can undertake compute, and so on. So it gives you absolute control over where your data lives and who can access it. Within your workspaces, you can have as many projects as you like, and these we envisage will be individual commissions or individual models. As with the workspace, you can specify a geofence around it, so you can specify that model happens in a given location, and that can reflect the model data you upload. Each project can inherit the permissions from the workspace, so you can specify everyone in your team has the same level of permissions over each project, or you can refine them on a project by project basis. There's a lot of flexibility embedded in the software. When you start setting up your projects, you need to provide some data, some project files. This is something that Flood Platform is incredibly strong at. So when you first upload a model to Flood Platform, we've made that process as easy as possible. So it may be you've received an existing model from a client in a zip format, or you've got a project which you've been working on within your own system and you want to transfer it to Flood Platform. Simply drag and drop the files into Flood Platform, and you can do this multiple times. The system can deal with multiple uploads simultaneously. When you start that transfer, Flood Platform identifies what sort of solver, what sort of software is being used. Is it HEC-RAS? Is it SWMM? Is it TUFLOW? And so on. And will scan the uploaded files for simulations, plans, batches. So it identifies what you've been running or what you potentially want to run. During that scan, we look for all the associated files required to run a model. We're looking for missing files, we're looking for file inconsistency. So it may be you've run 10 of your runs with one 2D grid and the remainder with a different 2D grid, or some inconsistent boundary conditions. So as part of that upload, we're checking for consistency, we're checking for missing files, and we're also drawing out the metadata associated with those files. So anything that can tell us about where the files were produced, who produced them, where they've come from, how old they are, all that metadata comes out at the same time, so you can better understand the model files you've uploaded. If any issues are identified, they'll be flagged to the user and they can take action to correct them, so missing files can be provided by the user. Once the simulations are uploaded, we break this down, once the model upload, we break this down into simulations, and also we break them down into boundary types, so what rarity of events, 1 in 2, 1 in 5, 1 in 10, 100, 1,000-year event. Try and detect what climate change allowances have been used, what scenarios or plans have been applied, what storm durations have been used. So that's part of drawing in this metadata. When we're scanning the files, we're trying to understand what was in them so we can give you that contextual information, and Flood Platform will attempt to fill in all that contextual information for you. It's not going to get it all right. So if there are gaps or there are blanks, you can override that and fill them in. But at least when you're uploading a new model, you've got a good start to understand what's in that model container and what you need to do with it. Once your models are up, you can run them in Flood Platform. So if they've not been run before or you want to rerun them, you can do that within Flood Platform. You simply select the simulations you're interested in and press go. They will be sent out to run in the cloud. Once they've run, they'll be brought back into Flood Platform and made available for you to access. You can choose to rerun existing models. You can choose to run using any versions of the solvers available. And if you've already run the simulations off Flood Platform, you can import the results directly. You don't need to run them in Flood Platform. The great thing about running in the cloud is the parallel working. So because we're spinning up lots of containers to run this, it takes as long to run one run as it does to take 5, 10, 100. So that all those simulations can run in parallel, allowing you to complete your simulations a lot faster. And you've also got a very easy way of tracking that simulation progress. You can see which ones are in flight, you can see which ones are completed, and you can see which ones have failed or have got problems during the simulation and take action to correct those as you go. Something I'm really excited about in Flood Platform is the ability to interpret and visualize your results once they're complete. So once your simulations are complete, either running in Flood Platform or on your local computer and uploaded, you can visualize them live in the web browser, both 1D and 2D results. What this will look like is your 2D results will be available in a map layer where you can pan, zoom around, change the background mapping, add contextual data like building locations, observe flood outlines, existing flood maps, and so on. But you'll be able to animate those results. You'll be able to pan backwards and forwards through the 2D results so you can see the flood propagation, the flood wave. You'll be able to see vector and raster data. So you'll be able to see both the flood depths, the hazard, as well as the velocity arrows, all within the 2D. And you can overlay multiple return periods all in one interface, as well as the ability to change the color ramps, the opacity, and all the other tools you'd expect to see within a GIS environment. With the 1D results, you can also visualize those in the same way you would on a desktop application. So for a 1D model, you can see hydrographs, you can see cross sections, you can see long section plots, you can see tabular data, and again, you can animate that where it's unsteady data. And the benefit of this is anyone in your team, whether they're modelers or not, can access this model data when you give them the right permissions and interact with this data without having to download information onto desktop, without having to use specialist applications. So it really democratizes access to data amongst your teams. Going a bit further than the models, because teams are interacting and working collaboratively within the platform, you can create customized dashboards that allow you to track what you're doing. You can understand which projects are live, which projects are using the most data, the most compute, what stage different projects are at, how long you've been working on them. So we can provide insight to help you manage your modeling projects. And the intention is we do this in an open way, allowing you to create your own dashboards, bringing your own tools into this, so you can better understand how your teams are performing and coordinate teams across different organizations, across different regions, across different offices. Reporting is a really strong element to what we're doing. Because we've got a structured way of managing the data, we can start to automate deliverable production. So things like model logs, input statements, reports, model passports. We can define templates, or users can define templates for these and decide where model data we brought in. So that could be flood maps, that could be lists of models undertaken, provenance of data. Because we've got the metadata for all the elements of your model, we can help you produce these reports a lot faster, more efficiently, and far more consistently between teams. We're not envisaging you'll do everything in Flood Platform, but at least Flood Platform will be able to allow you to collate all the key model information, and that it can be exported and finalized before handing over to clients. Also, any deliverables can be attached to the models within Flood Platform and then shared with the models. So the reporting, the deliverables live with the model data, so they can be associated with each other going forward. Collaboration is important. So I mentioned on the limitation slide earlier in the presentation how challenging it is to share models, particularly large, complex models, with your clients, with your partners, and also stakeholders. Because Flood Platform allows you to visualize model data within a browser, we can share this information with other people. So you can simply click to share, choose who you want to share it with, and the recipient will receive an email, direct them to Flood Platform where they can access this model data. And you've got very granular control over what they see. It may be you've got a technical reviewer who you want to give full access to all the data, be able to dive into the nitty-gritty, into the cross-section details, into the model configuration, see all the results and visualize everything. Or you may have a stakeholder you want to engage with. It may be a community group or a small client, and they simply want to see flood outlines. All those things are possible, and we can enable and will enable so in context client feedback and stakeholder feedback. So you can click on an area and provide comments. You can click on a model component and provide comments, and those will appear in line within the tool, allowing you to respond to them and keep track of what's going on. So a far easier way of managing commentary on models and providing feedback from your clients. Flood Platform is still in development, but we're looking to release a beta of Flood Platform in the coming weeks, and would really appreciate your feedback on it. On our website, www.floodplatform.com, there's a register for trial button in the top right-hand corner. If you want more information about Flood Platform or want to hear about the beta, we'd love to get some information from you. Just drop your details in here and you'll receive an email when the beta is ready to roll. We're looking to launch Flood Platform in October this year. This has been developed within Jacobs over the last 15 years, and we've been working over the last couple of years to develop this as a product which can be used externally. I'm really excited about what this can do, and we're really coming out now just to get people's attention, get their feedback on what we're doing, and hopefully you'll be interested in the launch.